router 4 is going to advertise this network with their both neighbor, right? To router number 2 also, to router number 3 also. Am I right, bro? Right? And it will share what bandwidth and delay. Then router 2 and router 3, both routers are going to advertise it with router number 1. And router 1 is going to calculate metric. So metric from upper side is 10 plus 15 plus 5, 30. And metric over here is 10 plus 5 plus 20, 30. So in this scenario, router is calculating same metric, right? No, 25, 25. Yeah, 35, 35. So from the upper side, router 1 is calculating least bandwidth. So upper path is the best path. Got it? Now let's suppose, guys, by default all links are fast Ethernet link. So router 1 is going to perform what? Load balancing. But you want to use upper path. So what you can do? You can increase some bandwidth of this link or of this link. Yes or no? Or you can decrease some delay of this link or this link. Correct? This is not the way which we are going to use to manipulate path. But this is also one option, right? Correct? So hope now metric calculation is clear, guys, to all how EIGRP is calculating metric. Just a minute. Now, routers, EIGRP routers are sharing bandwidth and delay with the help of update message. So I am expecting two types of messages are clear. Hello message and update message. And again, guys, we have two types of update message. One is null update message and one is main update message. Null update message means it is sharing only sequence number. It is checking actually bidirectional connectivity. Like in this scenario between router 1 and router 2, let's say both routers have formed neighborship. Both routers have formed neighborship with the help of hello message. Router 1 have sent their hello message to router 2. Router 2 have sent their hello message to router number 1. And now both routers are neighbor. But is router receiving any acknowledgement from router number 2? Has router received any acknowledgement from router 1, 2? No. Have router received any acknowledgement from router number 1? No. So there is no bidirectional, there is no security of bidirectional connectivity between router 1 and router 2. So both routers are going to send now null update message to check bidirectional connectivity. So in the null update message, as update message is the reliable message, right? Routers are not sharing actual network informations now. Both are sending null update message to check bidirectional connectivity. Means router 1 is sending one message to router number 2 to check am I getting acknowledgement or not. If I am getting acknowledgement, that means there is bidirectional connectivity. And as update message is the reliable message, when router 2 will receive null message of router 1, it will send what? Acknowledgement. And guys, all types of communication who are reliable, which are acknowledgement based, will use sequence number. Am I right? Because with the help of sequencing only, with the help of sequence number only, we can get acknowledgement. Like if router 1 is sending update message on sequence number 0, so router 2 will give acknowledgement on sequence number plus 1, means on acknowledgement number 1. So once router 1 will receive acknowledgement from router number 2 and acknowledgement number is 1, then it will get to know, okay, router 0, router 2 have received my this packet, this null update message. So use of null message is just to check bidirectional connectivity. And to verify it, what you can do, you can capture the link. Done. Should I capture link again to show you null update message, guys, between router 1 and router 2? Or you can check it by yourself so that I can move. To check, simply you can capture one link. Let me do one thing. Let me capture the link. And I'm going to down the neighborship between router 1 and router 2. Simply I'm going to remove 12 network, router EAGRP S number 10, and say no network 12.1.1.0 255.255.255.0. Then earlier both router was sending hello message, but now only router 2 will send hello message. See, only 12.2 is sending hello message. Now again I am going to up the neighborship. So let me run network 12.1.1.0 255.255.255.0. Right? Now you can see the messages. First of all, both routers have exchanged hello message. Correct? Now I'm going to disable the capturing. Stop the capturing. See, router 2 have received the hello message from router number 1. Now router 2 is sending what? Update message. And which type of update message it is? It is null update message. How can we verify that? You can see in the null update message it will not share any network information. So there is no network information. What informations are there in the null update message? Again, ES number, acknowledgement number, sequence number. What is the sequence number here? 10. Means router 2 have already shared 9 update message to router number 1. Whenever, guys, always keep in mind, whenever change will occur in the EIGRP, it will update their database, it will update their topology table with higher sequence number. Right? So now here also you can verify the sequence number on router number 2. How? So IP EIGRP neighbor. So you can see sequence number of router 1, router 2 is 8. If you will add one network on router number 1, it will increase sequence number by 1. If any network will goes down, then also it will increase sequence number by 1. It is not like it will decrease sequence number by 1 if network will goes down. If any change will occur, if it will not increment sequence number by 1, then guys there is no logic of sending update message. See, now the sequence number of router 1 on router number 2, for this neighbor, for 12.1.1.1, for this neighbor sequence number is 8. Let's suppose now router 1 is receiving an update message. First EIGRP will check sequence number. If sequence number is 8, then it will come to know that no, this is not for me. This is not useful for me. Why? Because I have already updated with sequence number 8. I am already updated in database. But if router 2 will receive update message your sequence number is 9, then router will say, oh, sequence number is 9. I have database of 12.1 with sequence number 8. That means there is some new information. That means there is some new information. So I should check it. Then it will open. So if sequence number is higher, then only router is going to open the update message. Otherwise it will discard it, right? And same process will work in case of OSPF also. So in the null update message, there is nothing. Then guys, source IP address, 12, router 2 IP address, destination IP address. Unicast or multicast? Unicast. So always keep in mind, null update message is sent on both address. Multicast also and on unicast also. Like this time router 1 and router 2 want to verify the bidirectional connectivity. Like router 2 want to check bidirectional connectivity with router number 1. So it will send this message to router 1 only. right? Not like if there is some more router connected with switch like this, then it will send to all routers. No, router 2 is checking connectivity, bidirectional connectivity with router number 1 only. And when it will send on multicast address, suppose router 2 need to share some network information, so it will generate main update message, and this time router 2 need to inform about that change to all routers, right? So it will send this update message to multicast address, right? So anyone can ask you this question. Router send update message on what address, multicast or unicast? Interviewer can ask you this question, so always keep in mind on both address. Hello message also, guys. Hello message can be sent on unicast address or can be sent on multicast address. Actually, in EIGRP we have two types of neighborship. Now you can see routers are sending hello message on multicast address, right? 224.0.0.10. So this is dynamic neighborship. In dynamic neighborship, EIGRP will send hello message on multicast address, but in case of a static neighborship, EIGRP will send hello message on unicast address. So it is not sure that every time EIGRP is going to send their messages on multicast address. No, right? So null update message will be sent at multicast, sorry, unicast address. So destination is, that's why unicast. Destination MAC is also unicast. MAC address of neighbor. MAC address of neighbor. Neighbor should be in same network, in same subnet. This is the requirement of neighborship. Subnet mask and subnet should be match. So it can resolve the MAC address of neighbor. Right. So this is update message of router 2. Then see the hello message. Next hello message of router 1. If you will open this hello message, see the acknowledgement number somewhere is 0. I'm not talking about this one. Update message of router 1, update message of router 2, null update message of router 1. Guys, what is sequence number in this message? Who is sending? Router 2. And what is sequence number? 11. So router 1 will send what? Acknowledgement. So see the acknowledgement. Who is sending this acknowledgement? Router 2. So if you will open this message, sequence number is 6 here. So router 2 is going to send acknowledgement on acknowledgement number 5. This is actually acknowledgement of previous message. That's why here you can note, see the messages in correct order, guys, in the capturing, right? But what will happen in the scenario, let me explain here. First, router 1 will send hello message. To router 2. Router 2 will also send hello message to router 1. Both routers will become neighbor. Then router 1 is going to send null update message. After becoming neighbor, router will share null update message with their all neighbor, right? Let's say on this interface, router 1 have discovered 10 number of neighbor. So to all neighbors, it will send one null update message on unicast address, right? So let's suppose here sequence number in the null update message is 1 or 0. Then router 2 is going to send their null update message. And in the null update message of router 2, sequence number is 0. And router 2 can give acknowledgement as well, guys, with the help of same update message. With the help of same null update message, here it can say acknowledgement 1. So with the help of same message, router 1 will get acknowledgement as well as their null update message. This type of acknowledgement is called piggyback acknowledgement. This type of an acknowledgement is called piggy. Let me write here. Piggyback acknowledgement. Means if router or any device is not generating a separate acknowledgement message, it is acknowledging with the help of another message. That type of acknowledgement is known as piggyback acknowledgement. You can read about it on Google. This is not in your syllabus. This is just for your knowledge. Done. Now router 1 have to generate acknowledgement. Right? So again router 1 have two options. It is going to send the main update message. With the help of that message also it can acknowledge, or it can generate a separate acknowledgement message to router number 2. So acknowledgement number will be 1. Now both routers have become adjacency. Both routers have become adjacent to each other. Now routers are going to exchange what, guys? Routing table. So now router 2 will send their all routing information with the help of main update message on what sequence number? On next sequence number, that is 1. Sequence number 1. And this update message carry these all network informations connected with router number 1. In the same way, router 2 is also going to send the update message. After that, both router will share acknowledgement, will send acknowledgement. And that's it. After that, both routers are going to maintain their routing table according to the update message, and then both routers will be keep exchanging hello message to check neighbors are alive or not. Same process is happening over here, but here messages are not in the sequence, in the correct sequence. Like here you can see this is update message from 12.2, means router 2. So router 2 is sending update message with sequence number 13. So router 1 is going to acknowledge on acknowledgement number 13. I think it should acknowledge on 14, or maybe it will acknowledgement on same acknowledgement number, right? That is, I think, in case of a SYN message, SYN plus ACK and three-way handshake. Sequence number plus 1 is the acknowledgement number, but in EIGRP I think it will send acknowledgement on same acknowledgement number. Done. Then opcode is there, means message type, and hello message is nothing but your, sorry, acknowledgement message is nothing but your hello message, correct? It is using hello message. This is hello message. In the hello message we have sequence number field and acknowledgement number field. So right now you can verify it like this also. On router number 1 you can see the sequence number of router 1 is 8. If I will add any network on router number 1, like if I will create one loopback interface, loopback 1, and let's say IP address 10.1.1.1.255.255.255.255, do so IP EIGRP neighbor, and sequence number of router 2 is 13. Right now I am going to advertise this network in EIGRP. So router EIGRP 10 and network 10.1.1.1.255.255.255.255. Right, it will update their topology table. So IP EIGRP topology. So see, it have installed this network, and whenever it will update their topology table, it will increment in sequence number by 1. So IP EIGRP neighbor sequence number is, earlier sequence number was 13, now sequence number is 16 on router number 2. So IP EIGRP, now sequence number of router 2 is, guys, router 1 is 9, earlier it was 8. Now what will happen, router 2 is also going to install that network in their topology table. So router 2 will also install their, update their sequence number, and then it will forward to their next neighbor, to this neighbor, and this neighbor will also update their database, so that neighbor will also increase their sequence. Now what will happen if this LAN network will goes down? Then guys, right now router 2, router 3, these all routers, all neighbors have this network information. So IP route EIGRP 192.168.10.0. This network is present in the routing table via router number 1. So router 1 have advertised this network in EIGRP domain. That's why router 2 or router 3 have this network information. But if the network will goes down, then also this is the responsibility of router 1 to inform their neighbor to uninstall this network from their routing table. Yes or no? When this network will goes down, then it is the responsibility of router 1 to inform their neighbor, right? So to inform, yes, sequence number will increase by 1. Now sequence number will be 10. Earlier sequence number was 9. So when this network will goes down, sequence number will become 10. And guys, whenever this network, any network will goes down, router generate query message to inform their neighbor. So third type of message in EIGRP is query message. So this is the first use of query message. Again, there are two use of query message like hello. Hello is used to discover the neighbor and to maintain the neighbor. Query message is used to inform about the change to neighbor, about the network down, and to inform neighbor that now I don't have reachability to this network. If you have any alternate path, then share with me also. So actually what router 1 will do, router 1 will set metric maximum for this network. In the query message, it will set metric maximum like infinity. Route poisoning, remember route poisoning. It will send metric maximum. Maximum metric means the network is unreachable. So when router 2 will receive this network information with metric infinity, it will come to know, okay, now this network is not reachable from router number 1. So let me check. I have learned this network from router number 1. If yes, then I have to remove it. And know if I have any alternate path, if any alternate path is available in the topology table, because maybe there is one alternate path, guys. Maybe that path is not in the routing table, but topology table carry all possible path. So in the topology table, this path will be also there. Not like this, right? So there is still one path to reach in this network. Router 2 have that path. Router 1 don't have that path. So router will generate what? If router have alternate path, then router will generate reply message. If router don't have path, then also it will generate reply message. So guys, there are two types of reply message. One is positive reply. If alternate path is available, then it will send positive reply. In the reply message, it will send alternate path information, means bandwidth and delay. Take this bandwidth and delay, calculate the metric and install it in your routing table via me, like that. So query message is used to inform about the network down to neighbor and to ask to neighbor, if you have any alternate path, then share with me also. And guys, whenever a router will receive query message, it will generate what? Reply. And you already know the acknowledgement. As these messages are reliable, so router will send acknowledgement. Acknowledgement is nothing but hello message. So in EIGRP, we have 5 types of messages. Hello message, it is used to establish neighbor and keep alive. Hello time 5 seconds, hold on time 15 seconds. And it will send hello message on both type of address, multicast as well as unicast. It can send hello message on both address, unicast and multicast. Then we have update message. Update message is used to share prefix information of routing table, right? It is a reliable message. It is a reliable message. So after sending update message, router will expect acknowledgement, right? And on the serial link also EIGRP will send update message on unicast. Like link between router 1 and router 2 is if serial. Nowadays we are not using serial link, but in the GNS3 guys, in the packet tracer you have serial link, right? You can use serial link as well to connect two routers together. So on the serial link, EIGRP will always send update message on unicast address. Done. On multi-access link like fast ethernet link, these are multi-access link, means with the help of single link I can connect multiple and devices. Like you can see PC1, PC2. If I have scenario like this, these all PCs are connected with switch like this. So this cable can be point to point cable, right? Because my PC is only going to use this cable. But if you are connecting switch to router, so this cable should be what? Multi-access cable. Multiple users are accessing this cable using this cable. So this cable cannot be point to point. Point to point cable always used to connect two devices. Point to point. That's it. I'm talking about the serial link. But fast Ethernet link is multi-access link. So on the multi-access link, it will send unicast as well as multicast hello message. After sending update message, router will wait for acknowledgement till SRTT time. See in the hello message, there is one timer, guys. Yesterday also I told you I will tell about it later. So IP EIGRP neighbor. So what is SRTT time for this neighbor? 52 seconds. On router number 2, so IP EIGRP neighbor. SRTT time for this neighbor is different. SRTT time for this neighbor is different. Right? Router 2 have two neighbor. For router 1, SRTT time is 40 seconds. For router 3, SRTT time is 30 seconds. So if someone will ask you that after sending update message, router will wait for acknowledgement till what time? Till what timer? So that timer is, guys, SRTT time. A smooth round trip time. Okay, so router will wait for acknowledgement till SRTT time. If router will not receive acknowledgement within SRTT time, then it will send unicast message with same sequence number again. What I am saying? If router will not receive acknowledgement within SRTT time, then it will send same update, again update message with same sequence number. And this time router will send unicast, that message on unicast address. Again it will wait for SRTT time. Again if it will not receive the acknowledgement, then again it will send same message, unicast message, unicast update message on same sequence number with same sequence number. So till when router will be sending update message if it will not receive acknowledgement? So guys, router is going to send 16 unicast update message. After that, if it will not receive acknowledgement, then it will declare their neighbor as dead. Then it will break the neighborship. Again, if it will receive the hello message, then it will form the neighborship. Right? So always keep in mind that whenever a router is sending update message, it will wait for acknowledgement till SRTT time. If it will not receive acknowledgement till SRTT time, then it will send again update message on unicast. Earlier it was sending on multicast. This time it will send on unicast, and sequence number is going to be same. Like here sequence number was 10, so here sequence number will be also 10. Right? Because there is no any change in database in the topology table. So that's why sequence number is same. And why it is sending on unicast address, guys, this time. Wait, I'm going to give you one example of this also. Again, after sending one unicast message, it will wait for SRTT time. If it will not receive the acknowledgement, so it will send total 16 number of unicast packet. After that, it will declare their neighbor as dead. If router will not receive acknowledgement till 16 unicast update message, then it will break neighborship. Now question can be how router is going to calculate SRTT time. Is it your question? How router is going to calculate SRTT time? What is SRTT time? Guys, if this is your question, then tell me. So see, while sending null update message, as null update message is also reliable message. So when router 1 will send null update message, it will see after what time I am getting acknowledgement. Let's say I'm getting acknowledgement after 10 seconds. So that 10 second will become SRTT time. Actually, when router will get reply message of acknowledgement message in the response of null update message in 10 seconds, the router 1 will come to know, okay, generally it will take 10 seconds to receive reply, and it will set that timer as SRTT time. That time is as SRTT time. And you know, one more thing, guys. Sorry, I think I did some mistake here. See, router have sent the update message, but it have not received the acknowledgement. Now what router will do? Router will send again unicast update message, unicast, and it will wait for acknowledgement till RTO time now, not SRTT time. For the main update message, it will wait for acknowledgement till SRTT time, but now it will wait for RTO time. Right, so you can see router is maintaining RTO time also for their neighbor. So like for neighbor 1, router 1, SRTT time is 40 seconds and RTO time is 270 seconds. That means RTO time is multiplier of SRTT time. And guys, Cisco never revealed this, that how they are calculating RTO time. SRTT time is fine, that whatever time it will take to get reply acknowledgement of null update message, that will become SRTT time. Then actually router is multiplying some value with SRTT time and it is calculating RTO time. So you can see RTO is multiplier of 45. Right, so for the acknowledgement of unicast update message, it will wait till RTO time. Done. So for all neighbors, routers are going to maintain these two information, right? With neighbor, see, now read the complete information of neighbor. Router 2 is saying I have one neighbor that is whose IP address is 12.1.1.1, and this is sequence number, not that sequence number of neighbor table, right? Like in the table, if there are 10 neighbors, so it is going to give sequence number 0, sequence number 1, 2, 3, like to this the neighbors. This is not sequence number, this is like sequence number, you can say, numbering, heading. So I have one neighbor 12.1.1.1, or you can say this is the first neighbor 12.1.1.1 means IP address of neighbor, on which interface on fast Ethernet 0/0. What is the hold on time remaining? How remaining hold on time is? That is 11 seconds. Means after 11 seconds, this router will discard this neighbor. But it is receiving hello message after every 5 seconds, right? So this timer, guys, will be resetting after every 5 seconds. Then uptime, till when my neighbor is up. So till 20 minutes 57 seconds, this neighbor is up. What is SRTT time? Means what is the time I will wait for acknowledgement after sending an update message. Then RTO time means the time I will wait after sending unicast update message. Time till when I will wait for acknowledgement of unicast update message. Then guys, qcont is 0. That means this router is not waiting for acknowledgement. This router is not waiting for acknowledgement from this neighbor. Guys, sometime in the troubleshooting you will see qcont is 1. So if qcont is 1, that means a router have already sent the update message and it is waiting for acknowledgement. So whenever router will not receive acknowledgement, it will increase qcont. It will increase qcont. Clear? And then we have what? Sequence number. This is how we read EIGRP neighbor table, and these informations are very important for troubleshooting. And guys, as I told you, EIGRP is important protocol. We are using it. You have to learn everything very carefully. Like here, if I will configure one command, C interface F0/0, not 0/0 like this, router EIGRPS number 10, and say passive interface fast ethernet 0/0. Now you are the network engineer in this company. See, issue is what? So IP EIGRP neighbor. There is no neighborship between router 1 and router 2. How you are going to troubleshoot? Customer is complaining there is no connectivity between LAN 1 and LAN 2. Right? Let's say one LAN is connected with router number 2 here, which is 192.168.20.0/24. What I can do, simply I can create one loopback here on router number 2, and I can advertise that loopback in EIGRP interface loopback 1, say IP address 192.168.20.1 255.255.255.0, and router EIGRPS number 10 and network 192.168.20.0 255.255.255.0. Now 10.1 is not able to ping 20.1, so IP interface brief. Okay, network is up, ping 192.168.20.1. How you will troubleshoot? Customer is complaining that these two users are not able to communicate. So first of all, you are going to identify which routing protocol is running between router 1 and router 2. Okay, EIGRP. That is fine. Let me check. So IP protocol, basic configuration of EIGRP here. So IP EIGRP neighbor. Oh, really? There is no neighborship. What to do? What to do? Simply, guys, you can check. You can run one command, that is so run section EIGRP. It will show me all EIGRP enabled command on the router, right? So see, router EIGRP 10. Okay, this is correct. Passive interface fast ethernet 0/0. Okay, is fast ethernet LAN interface? Yes, fast ethernet is the LAN interface, so this interface should configure as passive, no problem. Network, I am advertising 10 network, 12 network. Okay, correct wildcard mask and 192.168.10.0. Okay, everything is fine on router number 1. So IP protocol. Okay, routing protocol is EIGRPS number 10. Is there any filtering? No. Okay, what K values they are using? K1 and K3, because there is no neighborship, so you should check K values as well. Previous command was this one. So run section EIGRP. Okay, so router 1 is using K1 and K3. You can verify it on router number 2 also. The router 2 is also using same or not. You can verify the AS number, that on both routers AS number is same or not. Then advertise network or interface, you can say in EIGRP. Routing for what network? Passive interface configuration. And like this, if I will run these two commands on router number 2, then I can find the issue. So on router number 2, so IP protocol. EAGRPS number is 10. Okay, this is correct. There is no any filtering. Fine. It is this router is also using K1 and K3. This is also correct. Variance of these are same. Okay, 192.168.20.0 and 23. This is also correct. I am doing routing for these all network. That is fine. And the passive interface fast ethernet. Oh my god, fast ethernet 0/0 is not LAN interface. Yes or no? Right? So I have find the issue and now I can fix it. Now I can remove this command, or simply to find the command I can run section EAGRP, right? So see the misconfiguration over here, this command. So I need to remove this command. Say router EAGRPS number 10 and no to this command. Now again you can see the log message. So IP EAGRP neighbor. Now we have neighborship, right? On router number 1 also you can verify. So IP EAGRP neighbor, we have neighborship. Now let me check the connectivity. Ping 192.168.20.1, source 10.1.1.1. Yeah, now ping is working. So IP route EAGRP. Okay, done guys. Now if you are thinking that why we router is sending unicast update message after SRTT time. So see the reason. And before that, let me do one thing here. I want to show you some more messages like query message here. So what I will do, I will capture the link again. Close it and let me capture the link again. Either I can capture the link between router 1 and router 2, or I can capture link between router 2 to router 3. When I will down this network on router number 1, router 1 will generate what? Third message, query message, and router 2 will generate what? Reply message, and both router will give acknowledgement. So if acknowledgements are not arranged, guys, don't worry about that. Try to understand the packets, all packets. So now what I'm going to do, I'm going to down 192.168.10.0 network. So interface F0/0, I think of 0/0 this network is running. Yeah, on F0/0 and say shutdown. So IP EAGRP topology. Guys, see this network is still there, 192. Network is still there, right, in the topology table. Is network there in the routing table? No. In the topology table 190, it will store this network 192.168. Now this is 20.0. It have removed the 192.168.2.0 because it have received the reply message, right? It will, when it will receive the negative reply, it will remove the information from the table, from the topology table. But until and unless it will not receive the reply message from the router number 2, it will change the state of that network in their topology table from passive to active, right? What I am saying, whenever this network will goes down, first of all router will place that network in active state. Active state. Right now all prefixes are in passive state. Passive state means topology is stable, this network is reliable. And active state means, guys, this network is possibly down, right? So router will put that network in active state, then it will send query message. First it will receive the reply message from router number 2. If reply is negative, then router 1 will remove it from their topology table. It will remove from the routing table immediately, but not from the topology table, right? So first see the query message here in the capturing. So when I have run command no shutdown, so you can see router 1 12.1.1.1 have sent one query message. Open the query message. This is, guys, EAGRP query message. Source IP is IP address of router 1, destination is multicast, right? Query message is multicast. message. And which network informations are there? 192.168.10.0/24. And what is the metric? Metric is maximum here, like infinity for this network. Then router 2 will generate what? Reply message. So see the reply message. First router 2 have sent acknowledgement of this query message. See the sequence number in query message. Sequence number is 14. So guys, router 2 have sent one acknowledgement first on acknowledgement number 14. And then router 2 have sent what? Their reply message. In the reply message, see the network information. And if it is not sending any metric, if metric is infinity, that means this network is not reachable. And once router 2 will receive this reply message, it will first give acknowledgement to router number 2, then it will remove that network from their table. Now to verify you, what I can do, I can configure filtering on router number 2. I can filter EIGRP query message. So if router 2 will not receive query message, then router 2 will not forward reply message, yes or no? If router 2 will not receive query message, then it will not generate reply message. And until and unless router will not receive reply message, it will not remove that network from their topology table, and state will be active. So don't worry about the filtering. For filtering, I am going to configure ACL over here, guys, and this is our topic in upcoming days. Right? Maybe after 3 to 4 class, we will discuss ACL also in the route filtering. So on router number 2, I'm going to create one access list. What access list I can create here? Extended, I have to create extended ACL. Access list. IP access list extended deny 101 I will not configure like this. Access list number 101, I can say extended deny, then protocol is EIGRP, and source is, let's say, NE, and destination is also NE. So this access list is going to filter all messages of EIGRP, but till now I have not applied it on the interface. So till now ACL is not working. Before applying the ACL, I have to configure, I have to increase hold on time, guys. Otherwise never SIP bill goes down between router 1 and router 2 after 15 seconds. So I don't want that these two routers should break the neighborship, because I want to show you practical, right? I want to show you this network in active state. So I'm going to increase hold on time of EIGRP, right? Yeah, I will apply it on interface, but later. Before that, let me configure. Let me increase the you you can apply it under the EIGRP protocol also. We have multiple options. Don't worry about the ACL na. We'll see it later. We can apply it in the routing protocol also, on the interface also. I can apply it on the other interfaces like virtual interfaces as well, like online VTY, where you are configuring Telnet and SSH. So I have multiple options to apply it. Then route map, we have in the route map also we can call ACL. We have PVR, policy based routing, quality of service, right? Many, we are going to use access control list. Don't worry about the access list. Now I am not applying it. Before that, I will increase the hold on time. So say IP hold on time for EIGRP, yes, number 10. Let me set hold on time. Done. And let me copy the command. I will set the hold on time on router. I will increase the hold on time on router number 1 also. F0/1. Let me paste the command. Now show IP EIGRP neighbor. You can see the hold on time, right? Remaining is around 9,000, right? So now I am going to apply the ACL on guys F0/0 interface. So interface F0/0, say IP access group number 101 and direction in. So in direction it will filter EIGRP packet, right? And before that, let me up the main network 192.168.10.0 interface F0/0, say no set, right? So IP EIGRP topology 192.168.10.0. So you can see this network is in topology table, right? Or so IP EIGRP topology. And state is guys passive. Now I am going to apply ACL on router number 2 and I will down this network. Interface F0/0 say shutdown. And so IP EIGRP topology. State is active for this network. What it's saying? Inaccessible, right? Why this router have this network? Because guys, router is waiting for reply message from the neighbor. Before removing this network from their topology table, it will generate one query message to their neighbor to ask, do you have any alternate path? First thing, if you have learned it from me, then first remove it from your table. And if you have any alternate path, then send to me also. But what is the issue? Router 2 is not generating reply message, right? So IP route EIGRP, no. So IP EIGRP topology. In the topology, state is active. And so IP EIGRP neighbor. Q count is 1 for the neighbor. Why Q count is 1 guys? Because it have not received the acknowledgement as well of the update message. So if Q count is 1, that means it is waiting for acknowledgement. Got it? So IP EIGRP neighbor. We have still neighborship, right? So in the troubleshooting, you will check Q count. You are going to check topology table. If any prefix is there in active state, that means there is some issue. State should be passive. And see, with this network we have many more informations, like this router is stuck in SIA, means active in state, stuck in active state, stuck in active state. So anyone can ask you like, what is active stuck in active state in EIGRP? So whenever a router will send query message to their neighbor and it will not receive the reply, if it will not receive the reply, then guys, that network will goes in active state. And if it will not receive acknowledgement, then it will get enter in stuck in active state. So now this network is actually stuck in active state. Clear? Timers. Now you can see neighborship is now neighborship bill goes down. After some time, neighborship bill goes down. Now you can see router 1 have removed that network from their topology table. So after sending update message, it will increase queue count by 1. It means I have sent the update message and waiting for acknowledgement message. But now you can see the queue count. So IP EAGRP neighbor queue count is 2. Now router 1 is waiting for 2 acknowledgement. It have missed 2 acknowledgement. So if you are able to see the neighbor here, that neighbor is present in the neighbor table, but still there is some issue in EIGRP. Check the queue count. This is guys issue. So how to troubleshoot it? Simply I need to remove access control list from router number 2. So go to interface F0/0 and I'm going to say no to this command. Now router 2 is going to send reply message, right? If now router 1 will send query, then it can send the reply. So IP EIGRP neighbor queue count is now 0. So on sorter will receive acknowledgement, queue count will become 0. Done. Whenever you will see queue count 1, that means device is waiting for acknowledgement. Now why second update is unicast? So guys, let's suppose here I have a scenario like this. R1 connected with one switch, then I have one router here R2 and then R3, and here I am running what EIGRP protocol. Okay, here I have one subnet that is 10.1.1.0/24. So router 1 is going to send update message to their both neighbor, to router 2 also, to router 3 also. Let's say router 2 have give the reply, but router 3 have not give the reply. So what router 1 will do? If router 3 will not send acknowledgement, then R1 will send unicast update message to R3. Why unicast? Because if this router 1 will send it to on multicast address, then guys switch will forward it to router number 2 also. Yes or no? So that's why router 1 is sending on unicast address, because router 1 need to send it to router 3 only, because it have not received acknowledgement from router number 3 only. Otherwise router 2 will also receive update message with same sequence number, right? And when it will check sequence number is 10, it will drop it. So every time this router have to encapsulate at layer 2, layer 3 as well as to EIGRP protocol. Now if you are thinking that why I will create this type of topology, so guys, this is real time scenario, I must tell you. See, this is not like this. One router 1 is in US, this one is in India, this is one, let's say, in Australia, right? We have 3 branch and all branch are connected together through internet, and I am running what EIGRP protocol. This is the actual scenario, right? So unnecessary one branch devices will receive 16 unicast query messages every time it will decapsulate. Getting my point? No, in the why I'm saying see switch, because switch is ISP, brother. All these interfaces are connected together with the help of ISP. ISP will give you one public IP address over here, that is, let's say 1.1, here 1.2, and here 1.3. All IP addresses are reachable with each other. So now I can configure EIGRP here, right? I can create the tunnel, I can configure the EIGRP. Here I can have two types of topology, full mesh topology or a spoke hub and a spoke topology. Like let's say I have internet circuit between these two branch as well as these two branch. I don't have any internet circuit between this one. So here you have to configure a static EIGRP neighborship. You need to form EIGRP neighborship between router 1 to router 3 and router 1 to router 2. Router 2 and router 3 is not going to form any neighborship because here you don't have circuit. Getting my point? Means these two branches are reachable with each other via hub, via main branch. Maybe this is a headquarter, right? Or main branch. So one main branch is connected with two spoke branch. So we can say this is your hub router, this is a spoke 1, this is a spoke 2. So in this scenario, you need to form EIGRP neighborship between router 1 and router 2 as well as between router 1 and router 3. You don't have any circuit over here. So how these two LANs will extend each other? Router 1 will forward to main headquarter will forward it to other branch, like this. Or you can have here also one circuit. Now you have EIGRP neighborship here, here, and here. This is full mesh topology. Earlier scenario was hub and spoke topology. This is full mesh topology. All nodes are connected with each other. So in this scenario, let's suppose router 1 is advertising this network to branch offices and it is not receiving acknowledgement from one branch. Then it will send unicast message, 16 time unicast message to all other branch as well. And guys, here I have only two branch. Let's suppose I have 1,000 branch. So is it bad or not? Right? So definitely it should send on unicast address. Why I am explaining these things? Because interviewer will ask you these type of questions only. Why it will send second message as unicast? Got it? So now you can explain it with real time example. All clear, guys? In EIGRP, SRTT, RTO, neighborship, update exchange, messages, content of hello message, content of update message, content of query message, content of reply message. You can check these all messages in Wireshark. If you want to perform lab of this, what I can do, simply I can connect to router with switch like this, right? Do you want to see this lab also? I have topology, or you can practice by yourself. Here also, to verify this problem, what you can do, you can connect R1 to switch, then R2 and R3. On R3 you can configure ACL, you can block EIGRP traffic. After that, here you can add one network, or you can dawn the network. So once you will dawn the network, when you will add the network, definitely it will generate update message, and router 2 is not going to acknowledge him, so router 1 will increase the queue count for this neighbor. Interviewer can ask you queue count also. Queue count is also very important questions for interview. Queue count, why unicast message in EIGRP, why second message is unicast after not receiving acknowledgement. So you can perform lab by yourself, these type of labs, or you can let me know, I will do it. Done. Now what next we have in EIGRP? And guys, if I have a scenario like this, like R1 connected with two router, R2 and R3. R2 is connected with two different router, 4, 5, 6, 7, 8, 9, 10, 11. Like this, if routers are connected, then what you will do? See what will happen. If there is one network, if this network will goes down, router 1 will send query message to both neighbor, right? Will these two routers generate reply? No. Both router will send acknowledgement, it will acknowledge, and then it will forward query message to their neighbor. Now these routers are waiting for reply message from their neighbor, right? If route is available, then definitely router 2 will generate reply message for router 1. But if route is not available, then it will not generate reply message until and unless this router will not get reply from their neighbor, right? Then router 4 is going to forward query to their neighbor, and router 1 is waiting for reply. So state of this network in topology table is active. All edge routers are going to generate negative reply. If router 1 will receive the reply, either it is negative or positive, doesn't matter, then there is no problem. If it will not receive the reply, then this network will stuck in active state. Okay, so always keep in mind, when this network will goes down, R1 will remove this network from their routing table immediately and change the state of this network in topology table. It will change the state from passive to active state. Means I have sent query message for this network and waiting for reply message. Edge router will generate negative reply. Edge router will forward to their neighbor. Like this, router 1 will receive reply message. When it will receive reply message, negative reply message means for that network still metric will be maximum infinity. Then it will remove that network from their topology table. So removing network from the topology table is fine, but if there is some network in active state in the topology table, that is not fine. That means your EIGRP network is not stable, bro. EIGRP network is not stable. And guys, router will wait for reply message till 180 second. After 180 second, this network will stuck in active. So for 180 second, it will put one network in the active state. Means for 180 second, it will wait for reply message. Within 180 second, router should receive reply message, right? So if router will not receive reply message within 180 second, it is stuck in active state. And whenever a network will stuck in active state, router is going to break neighborship. Now if you are thinking that, okay Praful, then what is the issue? If first network has goes down, router have installed it in active state, because it is not receiving reply, it will wait for 180 second. If for 180 second it will not receive the reply, network will enter in one active state, active stuck in active state. Then routers are going to break the neighborship. Then again it will form neighborship, both will send hello message. Bro, if both will form neighborship again, then assume the previous scenario, there are 1,000 branch, right? Both routers are going to share their topology routing tables again. All routers are going to update their routing table again in the scenario. If there are 10,000 routers, so 10,000 routers are going to update their topology table. For some time, network performance will decrease, goes down, right? So if neighborship is flapping, or if neighborship is breaking and again it is coming up, then what is the problem? Bro, we have problem. Network should be stable, then only it will work smoothly. Getting my point? Clear? So this is the issue, guys. Always keep in mind, if router will not receive reply message within 180 seconds, then router will consider it as stuck in active state and it will wait for 180 seconds. If it will not receive reply message within 180 seconds, then it will break the neighborship. We have seen this, like between router 1 and router 2. Again, if I will apply ACL on router number 2, interface F0/0, and again I am going to apply ACL here, and again on router number 1, interface F0/0 says shutdown. So IP EIGRP topology. I think that network was already shut down. Let me down loop back one. So IP EIGRP topology. So 10 network is in active state. Right? If state is active, that means that network is in active state. So now timer is started, guys. Right? After 180 seconds, this router is going to break neighborship with router number 2. So IP EIGRP neighbor, and as this router have not received the acknowledgement, so you can see the queue count is also 1. How this router is resetting the time? So access list, on this access list we have 504 matches. Hmm. So yes, router can have two loopback interface now, two loopback in network also. One will break neighborship. No loop. We don't have neighborship with loopback, no bro. We have neighborship with the IP address which is running on this interface and this interface. Here we have neighborship and this network is going down. Yeah. No, I have done the loopback also now. I have done both interfaces are down. If there is one, another loopback, let's say loopback 2, so that is still up. Yeah, process is exactly same. Any question, guys? And we have one more problem. See, ping and 23.1.1.2. Ping is working, right? So IP EIGRP neighbor, because we have neighborship. And now Q count is 0. I think it have again re-established the neighborship. Somewhere you can see the log message. Right? New neighbor. New adjacency. So after 180 second, router will break the neighborship. Okay. But guys, if your network is as stable, then neighborship will be keep up. If neighborship is, this is what we are seeing to this type of issue, neighbor flapping. See, after some time, neighborship is going down and then again coming up. right? So you need to troubleshoot these types of issue, guys. And I think I need to design one topology like this also, because we have some concept here also, like if multiple branches are connected together, then how to configure EIGRP, like in full mesh or in hub and spoke. So tomorrow I will design this lab. Then what we next we have in EIGRP, and EIGRP stub concept is also there. See, like here I have one subnet that is 10.1.1.0/24, and here I have one subnet that is 20.1.1.0/24. Guys, this is my hub router, let's say in India, and these branches are in different country or in different state, like Bangalore, Chennai, somewhere, and I am running EIGRP routing protocol, and we have hub and spoke topology. This time you can see all branch offices are connected with hub main branch, router 1, router 2, router 3, all these are branch offices. So how all branches will communicate? Via headquarter, via hub branch. Now suppose if this network will goes down, what will happen? Router 1 will generate query message for hub, and hub is going to generate query to their neighbor, right? But is it true, guys? Because see, who have advertised this network to branch offices? Hub router, right? Router 1 have advertised to hub router, and hub have advertised this network to all rest branch offices. That means all branch routers knows this network with the help of hub router, and now hub router is generating query. This is not true, right? It should not generate query. Or it should generate query just to inform the routers to remove this network information, but not to ask, do you have alternate path? To inform this router, what hub router can do, it can generate one update message. From that it will remove this network information, it will increase the sequence number. So once hub routers will receive updated sequence number update message, it will update their database with the help of message. But if hub router is sending the query message, then guys, all branch offices will generate reply. So to avoid this, if you want that the hub router should not generate query message, then you can configure hub router as stub router. Hub router as stub router. Command is very simple to configure stub on the router. Like I want to configure stub router to router number 1. So I can say router EIGRP ES number 10 and stub. Command is EIGRP stub, I think. Yes, EIGRP stub. So we configure like edge devices as stub, so that it will generate reply message. Now if you have configured hub router as a stub router, so whenever a branch office will generate query message, hub will generate reply. It will not wait for other branch offices reply message. Earlier, when a branch office was sending query message to hub was forwarding it to their branch offices. Other branch offices means other neighbors, and router 1 is waiting, right? If timer will reach to 180 seconds, then router 1 is going to break neighborship with hub router again. Done. So that's why we have this concept. Then guys, next topic in EIGRP is variance. Before talking about variance, let me discuss something here. Right. In this topology, guys, let's suppose metric from both sides is same. 25 and let's say 10. So metric from upper path is for 192.168.20.10.0 network. Metric from upper path is, guys, 10 plus 15 25 plus 10 35. and metric from the lower path is also 35. So metric is same on both path. AT value is also same because from the both side router is learning through EIGRP. If on router is learning same network from OSPF from the router number 2 and from the EIGRP from the router number 3, then it will decide which path is the best path on the basis of AT value. So AT value is useful in case of multiple routing protocol. If we are running multiple routing protocol, right? But if we are running same routing protocol, that is EIGRP in the entire domain, guys, then we are going to identify best path on the basis of metric only, right? And metric is same from the both side, means router is going to perform load balancing. Now we have two types of load balancing that this router can perform. One is per packet load balancing, and that is the by default behavior of router. Means first packet to, let's say, this path, second packet to this path, again this path, like this. Or you can change the algorithm. Second is per destination load balancing, right? So on the basis of destination, this is very useful in case of performance, for better performance. Let's say here you have one application, and this application is crucial for these users. So guys, you can configure one path for this destination only. So I can configure per destination load balancing on router number 1. I can say for this destination, please forward traffic to this path, then for this path, then to this path, for that IP. On the basis of destination also it can perform load balancing. Simply we need to run one command here to change the load balancing algorithm. Guys, by default is per packet load balancing. On fast Ethernet 0/0, I can say IP load sharing and put the question mark C, per destination and per packet. This is by default. Random destination, right? Destination doesn't matter. It will forward one packet from the upper path, one packet from the lower path. If all parameters are same, like metric, prefix length and AT value, not like everywhere. Okay, if everything is same, then it will install both path in the routing table and it will perform load balancing. Which type of load balancing? Per packet load balancing. But we can set per destination as well. Per destination, like this I can configure. Done. But EIGRP is the protocol which can perform unequal cost load balancing also. This is unique feature of EIGRP. This is unique feature of EIGRP. Now guys, here let's suppose metric is 5. So now what is the metric from upper side? 35, and from the lower side? From the lower side, 20. Which path is the best path? Lower path. So router 1 is going to install only one network in their routing table. D means EIGRP 192.168.10.0/24 and reachable via R3 and metric is 20. This is a routing table of router 1. If I will talk about the topology table, so guys, in the topology table there will be both path. State will be passive 192.168.10.0/24 via router 1 and metric. $20 and $35. So if primary link will goes down, router is not going to generate query message, right? if you are thinking that this path is the best path in the routing table and this is the topology table, so if you are thinking that if this link will goes down, then router is going to generate query message to their neighbor. No. If alternate path is available in the topology table, guys, then simply router will install that path in the routing table. That's it. It will remove this one and it will install other path in the routing table. That's it. So when router will generate query message, now a statement is changed. Router generate query message if whenever a network bill goes down, router will generate query message if there is no any alternate path available in the topology table. If alternate path is available in the topology table, any path with higher metric is available in the topology table, then it will not generate query message. That path will become best path and router will simply install it in routing table. But in the EIGRP we have feature so that we can install both path in the routing table even their metric is different. And guys, EIGRP have only capability to do this. No any other protocol can perform load balancing in this scenario if metric is different, but in EIGRP we can. So to understand this, how EIGRP can perform unequal cost load balancing, you have to understand EIGRP algorithm for best path calculation. What algorithm actually EIGRP is using to calculate best path? Actually, all routing protocol first learn network in their database like their topology table. Router have learn all network in topology table. Now it is going to run one algorithm over here. With the help of algorithm, it will find best path. All routing like OSPF is going to run their own algorithm to their database, and that algorithm will find best path. RIP routing protocol have their own algorithm to run on database to find best path. BGP have their own. So algorithm which EIGRP uses to find best path is dual. Diffusing update algorithm. Guys, we have some terminology of dual like feasible successor FD, successor, and RD, reported distance, or you can say advertised distance. And feasible successor. Sorry, this one is FD. Feasible successor means backup path, successor means main path, right? Best path in the routing table. Feasible successor means path available in topology table. Feasible backup path, you can say. If successor will goes down, feasible successor will become successor, like that you can say. Then FD is the metric from source to destination, and RD is metric from my neighbor. So you need to understand these four terms of dual algorithm, then you can configure the topology so that it can perform unequal cost load balancing. Okay, and guys, the concept, the feature I am going to use for unequal cost load balancing is variance. So tomorrow we will see variance, but before that, make sure whatever topics we have covered in EIGRP, guys, perform lab by yourself, design topology. Whatever topology I am designing, right, you can design this topology as well, hub and spoke. Or tomorrow I will design this topology in the GNS3. Then in EIGRP, after unequal cost load balancing, we have summarization. but you already know the summarization. And I have one another features as well for unequal cost load balancing, that is offset list. But offset list is one kind of equal cost load balancing, because see, with the help of offset list, what we can do, we can add the metric, right? Let's say router 1 is receiving same network from two different router. Here metric is 10, here metric is 20. So if I will add metric 10 on this interface, so guys, metric will become 20. Now you can see metric is same, so both it will install both in their routing table. So offset list is also one feature to perform unequal cost load balancing by adding the metric. Then you know the summarization, but we can perform on lab on summarization also. After that, I think in EIGRP, nothing is there, right? Then we will start route filtering, right? So maybe tomorrow or after tomorrow we'll finish EIGRP protocol. Clear? Clear to everyone?